So week 8, one session is already been done, right?
Yes, sir.
O- Okay. So we have to go through the activity questions and then practice one. So have
No,
everyone has went through the lectures? Have you seen the content?
Yes,
sir, I have
sir.
a doubt. Sir, I have a doubt in activity 8.1.
Yeah, we'll start with 8.1. So whoever has a doubt in 8.1, you can just ask me. I'll just write it down the question number and then we'll start.
Hello, sir. Hello.
Yeah.
Actually, the solve with us slides are not shared with us in supplementary content.
So all with us
Of,
will for which week?
of week 5 onwards.
Okay, okay. It will be done by tomorrow for sure.
Sir, there is one mistake in a practice assignment of week 6. Question number I mailed to support team. They said to you can ask in a
Okay.
Google Meet.
Yeah, you have
Okay.
to mail that to me or Shubham. Or you can mail me, okay? And then we'll
Question
check
number
it.
4. I think it's from graded assignment, week 6.
Okay, you can mail me that
How can I?
particular question. What are the mistake?
You
What?
How can I mail you? I don't have your mail ID.
Okay, vishal@study.iitm.ac.in. Vishal,
Vishal at the rate.
Vishal. Yeah, at the
Can you
rate
type in
study.
a chat box?
Okay, okay, I'll do it.
Sir, week 7 graded assignment solution is not released.
Okay. So the deadline has been passed already.
For week 7,
Yeah,
yes, sir.
Okay, then it will be done by tomorrow. Yeah. So what else is there? Graded assignment is not uploaded.
answer solve with a slides from week onwards.
Okay, so all with us slides are not uploaded. Okay.
And sir, in my dashboard, mock 6 is not visible.
So this is for you only or for everyone? I have
Um,
already forwarded your whatever you told. I guess from week 5 to 8 there was one more issue. So those things I already forwarded to the team. I don't know whether they have worked on that or not. So you asked for one more thing, right? So there was some
No, sir, I
difficulty in
ask
logging into
only.
the Discord.
Yes, sir.
So is that been done?
No, sir.
That is so. Okay. Okay, you can just send me your roll number once. Okay, in the Z chat itself.
Okay, sir.
Okay. Okay, so I have to write my mail ID, right? Okay, so let's start. Are you able to see my screen?
yeah,
No, sir, it is not visible. Yeah, now it is visible.
Okay, it's visible, right?
Yes, sir.
Hmm. Yeah, so activity. So first we have to discuss 8.1. Can you tell me the question number? Whoever has a doubt in 8.1, you can just ask me the question number. I'll just discuss those. Is this fine? Okay, tell me the question number.
So question number 2, 8.1, question number 2, and 5 also.
Okay. Okay. Anything else?
No, sir. For me, it's okay.
Anyone? Anything else? Okay. Let's start with the question number
Sir, seventh question also.
7. Okay. Let's start with the second one. So I'll just read it. Let f be a function and some figure has been given, and that figure is like this. Is going something like this, and here it is till 2, and then you have from here, so here it is circle, and from here again it is going like this. Here again circle, and this 4 from, okay, this is going something like this. Okay, so this is the function. Our function is this one. Okay, here it is x-axis, y-axis. Now, what have been you asked? Like, choose the set of correct options. Okay, the options, what are the options? The first option is limit x tends to, we are coming from left side, fx equals to 10. The second option is you are coming from x tends to right side, fx equals to 2. Your third option is limit x tends to 4 minus fx equal to 4. Here coming from right side, 4 plus fx equals to 4. And the last option is f is continuous at x equals to 2. And the same fx continuous at x equals to 6. Okay, so first look at the first option. So if you are coming from the left side, okay, so what is the value of 10? Sorry, what is the value of the function as 2? And okay, so then let me give you this also. This is 10 and this is 4. This is 2 and this is 4. Now if you are coming from the left side of 2, so if you are coming from this side, so this one, if you are coming from this side, so 2 minus means you are coming closer to 2 from left side, right? Now what is the value of function at 2 minus? At here, not exactly at 2, before 2. So 2 minus some smaller value. What is the function value? Can you tell me the function value?
10.
10, right?
Yes.
So the first option is correct. You don't have
The
any
function
problem with
value means,
first option.
sir, like, sir, function value, I'm not think it's like when it is LHL,
Not the
left hand
function
limit.
value. Okay, not. No. I'm just telling you,
Okay.
if you are coming closer from this left side, what is the
Okay.
function value at that point? So at exactly at 2, the function value is not
Is
defined.
10.
Okay, for this
not
function,
defined.
at least for this part, it's not
Yeah, it is
defined
not
for this
defined.
part.
It's not defined because it is circle.
For this
Yeah,
part.
okay, sir.
But if
Yeah.
you are coming from left side of that, if you are subtracting some small value, some h tends to very small, h is
Yeah.
tending to 0.
H is
Now the
infinitesimal.
value
Yeah,
would be,
it is.
it will be around 10, not exactly, but it will be limiting to a 10, correct?
Okay.
So
Okay,
this
yes,
is correct. The first option is correct. Fine.
fine.
Now the
Fine,
second option. So the second option, if you are coming from right side, now what is the value of function? So
2.
if you're at exactly at 2 also, the function value is 2, correct?
Yes. At 2 and 2 plus it is 2.
Yeah, at 2 plus, if you are adding some small value also, See, if you are coming from this side, what is the value? The function value is limiting to 2, right?
Yes, sir.
If you are coming from this side, right side, okay. If you are coming from right side towards 2, if you are tending, if your x is tending toward 2, what is the function value at that point?
It is 2, sir.
See, it's 2, right?
It is tending.
That's why
Yeah, it is.
that's tending toward 2, correct?
Yeah.
So that's why the second option is also correct.
Okay, okay.
See, if
Okay,
I'm
sir.
asking you, if there was an option 2 minus the function value was 2, was that correct?
No, sir. So because 2 minus it is approaching to 2, but not exactly 2.
See, no, I'm asking if I'm coming from left side, and then I'm asking what is the function value at if I'm coming from left side towards the 2. Is the function value 2 there?
No.
No, sir. No.
No, right? So that's why if the function value was given 2, then this was an incorrect option, but it is given as 10 because as we are tending toward 2 from left side, the function value is tending toward 10.
Okay, right, sir.
Yeah. So now you can see the third option. If you are coming to the 4 from left side, from this side, okay. Now what is the
Okay.
function value tending toward?
10.
Tending to 10.
10.
Again.
Tending to 10, right? So this is incorrect. Now if you are
Okay.
coming from right side, what is the function value tending toward? 4, right?
4.
So
Exactly
if
4.
you
Yeah.
see that 4 plus h, so 4 plus h will be somewhere here, right? And then if you see the value, it will be around 4. It will be tending toward 4 because you are coming from the right side, correct? So the function value will be start tending toward 4. So that's why
Okay.
this is also correct option. Now, how generally you check the continuity at x at
Sir,
any
it is not
particular
continuous.
value?
That I know. Both the options
Yeah.
are incorrect because it is we are lifting the pen and
No,
it is not
at
continuous.
6,
At 6,
at 6 it is continuous, right? At
continuous.
6,
At
this will be
6.
6. Yeah, this is 6, right?
At 6. So why, sir? Like this
See,
function, the whole function is not continuous.
yeah, that's the confusion. If you are asking about function is continuous at x equals to c, then you have to check neighborhood of 6. You don't have to go here and there. See, this function is being given. If this was given as if is f continuous, then you would have told this is not a continuous because you can see directly at 2 and at 4 it is not continuous, right?
Not continuous. Yeah. Yes, sir.
But it has been asked that whether the function is continuous at x equals to 6 or not. At 6
Okay.
the function continuous, right?
Yeah.
Because you have to
Okay.
check at 6 minus 6 plus and f6. So
Both the
all
LHL and
three will
RHL
be
will be.
same.
Yeah. Yes, sir.
Yeah, you can see
Yes.
that this value will be
Yes.
because if you are coming from left side, the value will tend towards this value. If you are coming from right side also, the value will tend towards this, and at
10 to that
exactly at
particular
6 also, the value will be exactly
The
6. Like whatever the value we are getting.
Yes, sir. Whatever. Okay. Thank you, sir.
Same is
Yeah.
also
question
case
number
with function is continuous at x equal to 3 also, right?
X equals to 3 also, it will be same. Yeah, correct.
At x equal to 1.
Yeah, x equals to 1 also. X equals to 1, you can see that this value would be there, right? If you're coming from left side also, this value will 10. If you're coming from right side also, this value will 10. And exactly at that point also, this will be the exact value, correct?
So, but this whole function as a whole, like
As
if
a
we
whole,
take
it is
this whole as a
yeah, as a whole,
it
it's
is
not continuous.
not continuous. Yeah.
Hmm.
Okay, sir. Got it.
So as you said, right, when we looked at x equal to 6, we have to see 6 minus and 6 plus. The value it will be almost same to 6. That
Not
is one
almost
parameter.
no. This value, I didn't know what is the exact value. This would be the value. This y.
Okay.
Let's for
Right,
example,
right.
this is y1.
Y1.
And that can be calculated because you are able to know these 2 points. You are already knowing that. Then you can get the straight line equation also. And then you are putting the value of 6. You can get this. And as you already know, linear line, like see, they'll be asking mostly whether the function is continuous or not. Okay, in whatever the domain they are giving. So you have to check in that domain. Mostly the domain, you just have to check it the starting point, the ending point. Okay, and then you have to check it the breaking point. But they won't, like, nobody generally gives you to check in the domain. Okay, they'll be mostly giving you at some point that you have to check. Maybe the function has been given, you have to just check at the breaking point where the function is breaking. Okay,
Function
let's,
is
for example, this is the
breaking.
breaking point.
Okay, function is discontinuous, right? Breaking.
Yeah, you have to, like, there can be possibility that this function would have been like this, right? There is the possibility, correct?
Right.
So at that time, this was a continuous, right? If this part, at least this part would be continuous if the function was like this.
Yes. Okay, understood. Okay. So is it also possible that I can say at x equal to 6 continuous, because if I start drawing from drawing
You can
4
say
to
that.
10, I don't lift the pen. Can I say
Yeah,
is that option also?
Yeah, you can say that. But the thing is, if you have been given the graph, you can directly say, right? From the given graph, you can directly say. But the graph is not been given, then you have to check it like this. Like, you have to calculate the limit at 6 from both the side, and then at exactly at that point. But if the plot has been given, then it becomes very simple to check.
Okay. I mean, with the an analogy of pen, it is also visible very clearly.
Yeah, it's correct, because you are not if you are lifting a pen, that means there is a breakage, like there is some breakage in the graph, and then that is not continuous.
Okay.
So now the next, who is the next question? Next one, so this is done. Fifth one. What is the fifth? Okay, so which of the following options are true? So this is like, okay, so which of the following options are true? There exists a continuous function from 1 to 5 to 1 to 7.
Like, I'm not getting this question.
Is there any graph already there?
Okay,
for
so
this question?
No, there is no any graph been given. I can see there is no graph been given. Okay, I guess there. I'm also not getting what the exact information been given here. Okay, is this the domain or range or what? Is this from? So there's a continuous function. There exists.
These are points at which the function is, like, it is telling that it is defined or not, or it is continuous or not. Sorry. At that particular.
Yes, continuous, not continuous, bounded, unbounded. They are checking.
Okay,
or Vishal, we have to draw the graph based on these options.
Correct.
Drawing
but
graph
the problem
are not possible.
Okay, let,
even if
for
it's
example,
possible, we don't know.
We're just taking fx equals to pi. So this function is some constant function.
Yes, sir.
Okay, there existed. So let's, for example, I'm just taking this as a some function. This is some constant function. Is this function satisfying our condition? From
condition of what? I mean,
so this okay. So the first option I think is a correct. Why? Because see, if you are taking any constant function, not just the x pi equals to, so this is one of the thing that I have taken, because this is satisfying our f3 equals to 3, f3 equals to pi. You just have to think of some random function. I just choose this random function where fx equals to pi, because this is satisfying my f3 equals to pi that has been given in the question. But I'm not getting what is this 1,5 to 1,7, whether this is a domain to range or this has been given 5 to 1, 7.
So it is a constant function. So, like, what to check there? Pi is a constant function.
Yeah, no, this is just asking, can there be a
It's
can
a
there be a continuous
it's a
function?
vertical line, right? It's a vertical line.
No, no, it's a vertical. Okay, you are taking 1,5 as 1 point and 1,7 as 1 point.
Yes.
I don't think so. That is the case. I guess this just telling that there's some
No, sir.
mapping from.
Points are. Yeah, it is some type of mapping. Exactly.
Yeah, this is a mapping only.
Points
This is not a
cannot be
point.
like this.
Yeah. That's why I was saying this is some domain or range. Okay, where and our first condition. Okay, so for why I'm saying that the first you can just think. So in this problem, they're just asking us to think. Are you able to think any continuous function f from this some domain to range such that this is getting satisfied? F3 equals to pi. Is there any function? So I'm able to think one, right? Function fx equals to pi itself. This is one function. This is a constant function. Okay, and this is a
Yes, sir.
constant function. I can think. Okay, so at least one function we are able to think in such way that this is satisfying our condition from this domain, whatever the domain 1,5, because we are not putting any values, right? So this is satisfying our this condition also d to r, correct?
Yes, sir.
No, how is it
Right?
satisfying, Vishan?
So like a sir,
Because
because
this is a
it
constant
okay,
function.
okay,
No, then we can
okay, got
also
it.
say that f of x equal to e. That is also a constant function.
But this is not satisfying f3 equals to pi, right? Is this satisfying this function? Not satisfying, correct? Because f3 is also equals to e only for whatever the function you told. But for me, this function is satisfying both the condition.
No, f3 equal
Sir,
to pi. I didn't understand. What is that? How it is satisfying?
Okay, because
so
f3
like the
equals to pi
domain and
because we
range.
don't have to.
Okay.
Okay, yeah.
So like the domain range is given there. So we put only the values that is in the domain for the
So 3
value
is
of
there,
x value.
yeah, so 3 is there in the domain.
Then only we will get. Yeah,
No,
3
no,
is there.
see.
Even if we if we put 4, then also I think the value is pi only.
You'll be getting pi only. Yeah, correct. You'll be getting pi only. But at least we are able to think of one function. This is just asking, is there exist any continuous function? And whatever the function we took, this is a continuous function, right?
Yeah, it is a continuous one.
So any
Yes,
function, any constant function is a continuous. But the problem is we have to choose that function, one particular function. There can be any number of function that we are not caring about. We just have to
so
think
like I
only
think,
one
sir,
function that
it is
is
a codomain, sir, because it cannot be a range, sir. If it is a range, then all the values in
No,
from 1
it's
to
like
7.
a codomain. Yeah, correct. It's a codomain
Yeah.
only.
Okay. Okay, sir. Then it's fine, I think.
Okay, so the first
fine.
option is
Yeah.
incorrect, I guess.
Yeah.
Now come to the second option.
Sorry, Vishal. Can you summarize
Yeah,
again?
I'm just saying that. So there are some 4-5 options is given, and this question I'm also seeing for the first time. So what I thought is, so it's just asking, is there any function, continuous function, from some domain to codomain such that f3 is equals to pi? Okay, is the statement correct or not? This is just asking. Now you have to think of one function, at least only one function you have to think of. Okay, we thought of, you can think of any constant function. Okay, any constant function, that is fine. But the problem here is f3 should be equals to pi. So then what is the function that can come in your mind is a constant function that is y equals to pi, that is parallel to x-axis, the value is pi. Because if I'm taking fx equals to pi, that satisfies our condition, whatever the condition that has been asked to satisfy. So two condition has been given. One is like some domain to range, and this is also getting satisfied because there is no x here, right? So everything will satisfy here. Either 1 to 5 or 1 to 7 also will satisfy. So there is no problem in that because the constant function will go from r to r, not r to r. Like it will be always same values only, right? Are you able to understand? If I am taking one constant function, some domain, codomain has been given. We are not worrying about because it's a constant function. Okay, so it will satisfy about that thing also. And now the other part is two condition has been given. First, domain codomain is getting satisfied. The second part is f3 is equals to pi. And if I am taking fx equals to pi, then f3 equals to pi is also getting satisfied, right? See, if I am having a function, if I have been told to consider one function such that f3 equals to e, and if this was the case, then whatever you told was correct. I can take y equals to e, where because why I can choose this, because here f3 is equals to e. At 3 the value is e, that is fine. But here it has asked me to choose a function where f3 equals to pi. So I have chosen y equals to e. Y equals to pi I have chosen. This is like some 2.71 or some value e. This is e and this is pi. I have chosen pi. And this is a continuous function, right? There is no breakage in that.
Yes.
Correct?
Yes.
Yeah. So that's why the first option seems to be correct. Now come to the second option. The second option is saying that there exists
So it is also correct. The same thing,
a
I think.
continuous function from some 1,10 to 2,8 such that f1 is 3 and f10 is 5. Are you able to think one continuous function where this value will get satisfied?
Both the conditions should get satisfied, is it?
Yeah. Both the conditions should get satisfied.
Sir, can you explain?
Okay, tell me the function. Are you able to think of one function? I'm also thinking.
Sir, can you explain that function? How it is satisfying? Actually, week 8 is quite hard to understand all the concepts.
Okay. So the first okay, so this like I don't think so this type of problem is going to be asked, but I'm just telling you the first option. In the first option they have just told you to think. Are you able to think any continuous function? I don't know, like in the first vision when I saw the question, now I thought okay, there must be some graph and all, but there is no graph, just telling you to think about some function. Are you able to think any function where f3 is equals to pi and they're having some domain and code, like codomain? Okay. So now I've just think of one, because it's asking for the continuous function. Okay. If we are asking for continuous function, you already know that if you have any constant function, that will be a continuous in any domain or range, whatever has been given to you. Because this is a constant function, right? It will always be continuous for whatever.
Exactly.
Like
I mean, Vishal, the point is what you told just now. Since this is a constant function, it has to be continuous, right?
Correct.
We don't need to have to look into a domain and range now here.
But they have given you some small part of that I told you. For a continuous function, they can give you a small part, and then you have been asked to check whether in the small part that is continuous or not. Okay. So I have think of
and this pi falls in this range and domain, is it?
Yeah, 1 to 5. It's like if this is a domain, like I'll come upon this maybe in the next session, but now I'm thinking this as a domain and codomain. Okay. If I'm thinking this as a codomain and domain, so 1 to 5 is some domain has been given to you. So this pi, whatever the function I have taken, so this will satisfy, right? This will be from R to R, correct? So but I have to take a small part of that to codomain. Even though if I'm taking a small part also, that will be continuous, right? In that domain also, correct or not?
Yes.
So that's why I've taken this function, and I just have to choose only one function. I don't have to take, like, they're just asking, is there any function? I'm just telling there is one function, and if there is a one function, I can say that the first option is correct. This is what
for example, on the same lines of thinking, what you're doing, what should be the domain or range which I have to modify here, which doesn't fall under this f of 3 equal to pi?
There is no range where, because this function is a constant function.
Constant, exactly. I mean, there is no significance of domain and range here. That's what I'm saying.
Yeah, correct.
Right. Similarly, the next question.
Yeah. So the only thing that you have to check is to think of the function, and that's why they have given f3 equals to pi. I guess that's why they have given f3 equals to pi, because pi is the only function that you can think of.
Like, sir, for this particular option, f of 6 is not defined.
F of 6 is not defined, yeah. But from whatever the
Yeah.
see 1
Okay.
to 5 they have given, 1 to
Yes.
5 is continuous,
discuss
right?
करे थे उनको क्वेश्चन
1 to 5 it's continuous, correct?
हाँ.
So we don't have to think about the 6, 7, 8, 9.
Yeah.
Sir, 1 to 5 means 1 is on x-axis and 5 on his y-axis. Like that, na?
No. If you have been asked to see the domain 1 to 5, that means from 1
1 to...
to 5.
Okay. And 1 to 7 is...
1 to 7 is the value that you can get.
Okay.
Okay. So the second option is
Understood. Okay. So the second option, if I consider f of 11, that will not come under this, right?
yeah, f of 11 won't come here. So now you have to think of a function that is satisfy this two condition, and also it will be should be continuous from 1 to 10.
See,
Are you
here
able to-
there could be multiple functions, right?
There can be, but we just have to think only one. If we are able to think one, this will be a correct option.
I mean, this question, what is trying to test us?
Just
Is it trying to test us? Find what are the functions in this 1 to 10?
yeah, at least one function you have to think. Can somebody tell me the function?
Like any function for this particular
Yeah,
domain and codomain.
and this should satisfy this both condition.
Like function like polynomial types of thing. I'm not.
No, any function,
any-
any if you are able to think of constant function, linear
So like
function,
fx.
anything.
X by 2.
Fx can be equal to 6 or can be equal to.
If we are taking fx equals to 6, that is not satisfying. F1 is equals to 6 here, right? F1 should be equals to 3 and F10 should be equals to 5.
That the function can be 2x minus 2x plus
Okay.
25 by 9.
2x plus
25 by 9.
25 by 9.
No, sir, entirely by 9.
Okay.
Whole by 9.
How did we
Okay.
get
Is
Like
this
this
the
is-
straight
This
line
is
that is
right.
passing
This is
through
right.
1, 3 and 10, 5? Is this a straight line that is passing through 1, 3 and 10, 5? This is
Yes.
how you have got?
Yes, sir.
Yeah, then this is the correct option, because if you see that, because this
So
is
like why, sir?
Yeah.
So why it is correct, sir? If it is correct, then why it is correct? Not it.
It is correct, because if you are putting the value of 1 here, what is the value you are getting? Is this at x equals to 1, are you getting 3? You put the value 2 into 1 plus 25 by 9, 27 by 9. So this is 3, right? So the first condition is getting satisfied. The second condition is
also
what?
correct.
F10 equals to?
F of 10. When we
So like
substitute,
how-
we get
right?
5.
How we get this equation, sir? The
This equation?
like the person.
Straight line
Right.
equation, right?
Yeah.
This is one point,
Like-
x1. If you have x1, y1 and x2, y2, can you get the equation of the straight line?
Yes.
Oh, okay.
Okay. Yeah.
Understood.
Right?
Okay.
Who gave the answer? Did she derive
Okay, sir.
the straight line theorem or just by trial and error?
Sir, I use the formula y minus y1 by y2 minus y1 is equals to x
Ah.
minus
Yeah, exactly.
2 minus x.
Yeah.
Okay.
Okay. Are you able to think any other
But
like
f of 1
equation?
equal to 3 and f of 10 equal to 5, how did you consider it as a points 1 and 3?
See, this is an equation, right? This is an equation. Whenever you are putting some value, this becomes a function. Okay, and if you are putting f3, so f3 becomes your y, correct?
Okay.
And whatever the value, x becomes your this one. So this becomes x1, y1. So whatever the value you are putting, whatever the value, exact value you are getting at some particular x1, that becomes your y1, right?
Oh, understood. Okay.
So this is x1 and this becomes y1, and this becomes x2, or whatever you want to take it, x1, y1. That can you can just shuffle also.
This is a very good input. I mean, I never thought like this.
Okay, yeah. So nice, whoever gave the answer. Are you able to think any other options also? Can we do it like?
Sir, we need not have a straight line. We can also have a curve, but then deriving the equation of the curve will be difficult.
Yeah, correct. So if I'm taking x minus 10, so at 10 it will become 0 plus 5. So then it will get satisfy the second option. But to satisfy the first option, at 1, it should get at 1 we should be getting how much? At 1 we should be getting 3, right? So 5 times x minus 1 . So if I'm putting at x equals to 1, this will get 0, but this will get 3 into minus 9, that will become 27. X minus 9. Then it will become this to already 0. Okay, leave it. Okay, this is a one, that option we can. So I'm able to think one.
Doing trial and error, right?
Yeah, that I was doing trial and error. I thought, okay, you can just multiply the, like, because at 10 it was getting 0, right? At 10 it was getting 5. So I thought, okay, because x minus 10 will get 0, plus we can add some 5 as a constant. But again, there is one more equation. At 1 it should get, your value should be 3, right? So then x, is this satisfying? 3x x minus 10 plus 5 x minus 1 x minus, this not satisfying or satisfying. At x equals to 1, should be getting 3 into 1. This is the 1 minus 10, so I'm getting negative value. Okay, leave it. So okay, 1, at least we got 1, so that is enough. We'll just move to the third option. The second option is also correct. What is the third option?
There exists a non-constant function f from R to R which is bounded.
So there exists a non-constant function from R to R which is bounded. So this too we can get right. There can, okay, non-constant function only, right? So non-constant function can be linear function. Linear can be bounded, right? No. From R to R which should be bounded. Okay, then it should be some curve like sine cos theta is bounded.
Yes, sir.
Right, from R to R.
This is also correct, I think.
This is like clear, right? This can for the third option we can able to think sin x, or you can think cos x also. Or yeah, this will work.
Vishal,
Yes.
can there be a constant continuous function?
Constant continuous function will be there, right?
Like
I can have a like x for the first function itself goes to pi.
Okay.
This is R
f of
to
x
R,
equal to pi. F of x equal to pi.
and
Okay,
the function is also bounded between pi
Yes,
to,
yes.
yeah.
Okay.
Okay, so the third option is also correct. Now what is the fourth option? The fourth option is there exists an unbounded function, unbounded continuous function from 2, 3 to R. So there exists an unbounded continuous function you want from, okay, so it's asking from 2 3 to R. So unbounded function would be something like 1 upon x or some type of this form.
X
If
by
you're
x
just thinking in
minus
that
2.
way, 1 by
X by x
x
minus
minus
2.
2.
Yeah. Because it's an open
Yeah,
interval
this
2, so 2.0001. Yeah.
correct. This is correct because it's open. So this should be 1 upon x minus 2, and upper you can write it whatever you want to write it, 1 upon x minus. So this is an unbounded function from 2 3 to R. Yeah, this is correct. Okay, so you are able to think. So all the four options are correct.
No, can you explain the fourth one? We did not understand.
Yeah, fourth one, the option has been given. The domain is open 2 and close 3. So this gave you a hint that in the denominator part you should be having x minus 2. Correct, because at 2 it is not defined, so that's why it has not included here in the domain. And whenever you are doing any form of reciprocal function, 1 upon x and all, you are you get an unbounded function, right? 1 upon, if you will start putting the value here, small value also, as the volume will get smaller, the value, the 1 upon x will get as big as possible. Okay,
Yes.
right? So that's why. Did you get that? See, if you are increasing the value, let's for example here itself 1 upon 2.1. Okay, setting some value 1 upon, if you're 2.1 minus 2, so you'll be getting 1 upon 0.1. So you're getting some 10, right? You can get as much closer to 2, like 1 upon 2.000002 minus 2. So now you're having the value will get as big as possible, right? So now the value will be 1 upon 0.000002, right? This is 3 3. So you'll be having 3 3. Okay, so now you'll be left with 10 to the power 6, correct?
Yeah.
So the value will start increasing as you are going closer and closer, because that is included in your codomain, right? Sorry, in the domain, not codomain, because all the value except 2 is there. So even the 2.000001 is also there, right? So if you are putting this value, you'll be getting a very large value. So this is making that function unbounded, right? From this 2 to R. So that's why this can be one function, 1 upon x minus 2.
And what about
So I didn't understand. Can you explain again?
Excuse me, sir. Why is this session not recorded?
Not recorded.
Or
I
like
guess
it is not on
recorded,
YouTube,
right?
It was not on YouTube, sir. That's why I asked. Generally, the sessions are available on YouTube also.
Okay, let me ask the team whether they have kept it on YouTube or not. So give me 1 second. I'll just call them.
Okay, sir.
Hari, meanwhile, you can explain here. Somebody's asking a doubt on this.
Yeah, the logic here is
it's not going on YouTube.
Go ahead.
Okay. Somebody asked me.
Yes, sir. I just asked. Sir, also put your device on charging. Your device is 8% only. Charge is only 8%.
Okay.
Hari, you can continue with the logic.
the point is it's an open interval 2 to 3.
Okay.
So when it's unbounded, what it means is the value tends to infinity.
Right.
Yes.
So like when you take a function like this, 1 by x minus 2, like sir said, like we can take a value 2 point, because it's open interval 2. So the next point that we can take is 2.000001, right? like and 2.00001 minus 2 is what? 0.00001, right?
Very,
Like
very
a large.
smaller value.
Yeah, so 1 by almost 0, which goes to infinity. So it's unbounded.
Again, please tell it again.
It's an open interval 2 to 3. So
Yes.
what happens is when we take a function like 1 by x minus 2,
Yes.
the
We
first
put
value
the
what we
value
want
of x. Yes.
the first value that we can take of because it's an open interval 2 to 3,
Yes.
right? For what is the least value that we can take? It's 2.0000001, right?
Yes.
So when you put that into this function, it's 2.00001 minus 2,
Yes.
which is
0.
0.00, and 1 by 0.0, it's closing like getting closer to infinity, right?
Yes.
So it's unbounded.
Okay.
So this is unbounded on the positive side, right? Right?
Yes, positive side.
If I have to take the unbounded on the negative side,
but our interval is open interval 2 to 3, right? So why would we? I didn't.
Okay, then you can take, if you want to take
domain.
unbounded in negative side. Are you able to hear me?
yes.
Yeah, then you can take it like this, minus of x minus 2. Okay, so it will be 1 upon some negative value of some very small value. Very small.
Sir, it is not live
Then
on
you'll be
YouTube.
getting. It's there. I've just checked with the team. They've told that it's mistakenly, like it was written some for the CT, so they have changed the YouTube link or something they have done. So it's there on the YouTube.
Okay, sir. Thank you.
Yeah. So is this clear? You can do it whatever you want to for the fourth option. Anything. Yeah, this is the function. One
But
function
if it
that
was a
we have.
closed one, we could have not taken this, right? 2.001.
Yeah, if this is that's why they have given the hint, I guess, to take that. Okay. Because if this was a closed one, then you would have taken something else, not this one, some different function. Can we move to the next question? What is the next question? The fifth one is done, right? Now let's move to the seventh one. Is this clear? The last one?
Yes, sir.
Yes, sir.
Yes, sir. Yeah.
Let's move to the seventh one. Okay, so the seventh. Okay, this function is fx. You have been given fx equals to x upon tan inverse 2x if x is greater than 0. Now the other thing is b, and then you have sine ax upon x. This is x equals to 0, and this is x equals to less than 0. How will you solve this problem? This is given that this is continuous at x equals to. Okay, so this is continuous function at x equals to 0. Then you have to calculate a plus b. How will you approach this? Just tell me the approach. How will you start?
No, how did you say it's continuous at x equal to 0? Where they have given?
It's given in the question.
If f is
given in
continuous,
the
if f is continuous, but where it is continuous, they have not given, no?
If this is
So
given
like,
continuous, that means like in all the function. Like see, for this function that has been given, this can be in like not continuous at one point, the breaking point. The breaking point is x equals to 0, and this it has been already given that the function is continuous everywhere. That means at x equals to 0 also it is continuous. Okay. Yeah. So
Means
if this
for all the
continuous,
points.
if this function, if fx is continuous at x equals to 0, or it is continuous, I am just skipping this. Okay, I can just delete this also. Then fine. That means if it's given at continuous at all the point at x equals to 0, you have to think that this is like continuous at x equals to 0. Now you have to calculate this value and then tell me the value of a plus b. How will you start? What should be there in your mind, the first stage?
First, we should find out the limit of the expression given for x greater than 1, x greater than 0. Limit x tends to 0 plus.
And sir,
Yeah.
also, sir, this f of 0 is also equal to b. It is given. Like
X
for the
equals-
continuity, we have to check for that particular point also.
Correct.
So at that particular point, x equal to 0, it is given fx is b.
Yeah.
F0 is b, sorry.
For any function, if that function is continuous at some particular value at a, what are the 3 steps that we do? 3 things we do, right? We check the limit. First thing is we check the limit, left hand limit, a minus, correct, of function, and then we check a plus, and that should be equals to what? The function at that particular point. If all these 3 are equal, then you can say that this is a continuous function. The 3 things that we check, right? For the continuous, we check 3 things.
Yes.
What are the things that we check for the limit? Whether the limit is defined or not at that particular point. Out of this 1 to 3, what are the steps that we check? We check
So
2
only 1
or
and 2.
3. How many things? 1 and 2 we check, and both should be equal, correct?
Yeah, both should be equal.
So
Then
for the
only limit
limit,
exists.
yeah, so there is no condition of this fa. This should not be, whether this is equals to fa or not, that doesn't matter. The only thing is the if you are calculating limit a minus should be equals to limit a plus is equals to some L or some constant value. This for the checking limit exists or not. But for the continuous, you have to check a minus equals to a plus equals to function value at a. Is this clear to everyone?
Yes.
Now I told you this thing. Now tell me, what is the LHS? How will you start? If you are coming from left side, so which function you should be checking? If you are coming from 0 minus, which function you should be checking?
Sin
Sin
ax
ax
upon
by
Sin
x.
x. Correct. So if this is a function sin ax, what was that? Sin ax upon x. Limit x tends to 0 minus. How will you do this? If you are putting at 0, can you see that? Can you use that L'Hospital or whatever you call that? Okay, that rule. Can you use this rule here?
Yes, sir. A will get.
This is in the form of 0 upon 0. So you can use this. How will you use this?
Yes, sir.
What is this rule?
So we'll differentiate.
You have to differentiate both the sides, like numerator and denominator. If I'm differentiating,
Numerator, denominator,
what is
yeah.
the differentiation of sin ax? What is the
Cos of
differentiation
x.
of sin ax?
Cos of x, sir.
Ax,
Cos.
and there should be something else also.
Yes, sir. A times cos of x.
A only.
Multiplication
Multiplied by
of what?
A.
A.
Upon 1.
1.
Okay. Can you put the value?
How you
now?
calculate that cos ax into x upon 1?
Okay. See, there is a rule. Whenever you have to calculate the limit, you can calculate with like the normal method also. But
Okay.
one beautiful method is L'Hospital. I call it L'Hospital. I don't know, this pronunciation is wrong, but it's like from the childhood I used to call this L'Hospital. So that's why I'm
Yes.
saying this. Okay. So this rule you can use it. And how do you use that? Is whenever you are getting 0 upon 0 form or infinity upon infinity, some indeterminate form if you are getting, okay, then you can
Yes.
use this rule to calculate
Yes.
the limit at some particular point. So I'm getting that if you are putting the value of here, this is sine 0 upon 0. So you're getting 0 upon 0 form. So I can
Yes.
use this rule. If I'm using rule, how generally you get the calculate this? You use this rule as you just have to differentiate till the time you are getting. See, if you are differentiating this, see if you are you can get any function f(x) equals to zx. So this will also, let for example, this is at x tends to 0. And if this is a function in if fx f0 equals to 0, and here also if you are getting 0 0 upon 0 form, so you can do this, right? F dash x upon g dash x. Okay, let's for example I'm getting f dash x equals to 0 again and g dash x equals to 0. Can I use this rule again?
Yes, sir.
Yeah, so you can use it again also till the time you are not able to. So till the time you are getting indeterminate form, you can use this rule. Okay, that's why this is one of the like good to like it will help you to calculate the limit at any particular day. Okay, so now you can calculate this, right? So sine ax upon ax limit, what was that? X tends to 0 minus. Now you can differentiate it. You'll get cos ax upon 1 multiplication of a. Correct? This is the left hand limit you got. Left hand limit you got. Now you have to calculate the right hand limit. How will you calculate this? If you are coming from the
Sir,
right
how
hand,
you
plus.
differentiate
So
that? Which method you use?
differentiation you know, right? Sin x का cos x होता है.
Yes, वो तो पता है.
हाँ, so if you have a function, if you are doing this function, if this is some gx and g के अंदर if you have some fx, so how do you do? Fx and then you are multiply f dash x also. This is how you do. So here
Okay.
sin x you can see that becomes your g dash. So you have to first difference. So you have to start from the outer part. Okay, you first differentiate sin x, like sin ax, whatever the function it is. Now go inside that. Now, so you can go it like that. Okay, so this is your left hand, and you can put the value of 0 here. If you are putting the value of 0, what is the value you are getting? What is the value you are getting if you are putting the value of
1.
So this
Cos 0,
becomes
1.
1.
Yes.
Multiplication of a. So you are getting L H L equals to a. This is what you are getting.
Yes.
Okay. Now come from the right hand side. 0 plus. Which function you will be taking into consideration to calculate the limit? Out of this 1, 2, which function you will be taking? Because third you have already used. If you are coming from x tends to 0 positive, so which function you will be taking? If you are coming from right hand side.
X by tan inverse 2x.
Correct. So you can use that one. X upon tan inverse 2x. Correct. Now how will you calculate the limit here? Are you aware of this?
So can we do here again like this L-Hospital rule? Can we use?
Okay, then you don't know the tan inverse ka, that you don't know, right?
So like the differentiation, yes, the differentiation is 1 by 1 plus x square. Tan
Okay, but
inverse
most
x
of the people don't know. Like we know, but most of the people won't be knowing this, right? So that's why I'm not using this method here.
Okay. Sir.
But if you are able to know, if you are knowing, you can use it. There is no problem in that.
So if this is the 0 by 0 form, yeah.
Okay. So no, then you have to. What is the value of tan inverse of 0? That you have to check.
Yeah.
Tan inverse 0 is what? If you are able to get 0 by 0 form, then you can use it.
Then only.
If you are not getting, then so better to multiply 2 here, right? And then multiply 2 here. Now you are left with what? 2x upon 1 upon 2 tan inverse 2x. And this you already know, right? Limit of x tends to 0 is equals to what?
1.
This one everybody knows, right? I guess, see, when if somebody is doing for the first time, you have to remember, okay?
So
Because
like tan x by x is 1.
Yeah, tan x
But
by x is 1.
but this function, like inverse function, we have not even like in the lecture there is no inverse function has been taken, and nothing like that. That's why I'm little confused here.
okay, if it had not been used, then see, you can do it with a basic method also, but the again the same thing, you have to mug up some of the limits, that is for sure, to calculate everything quickly. Okay,
So where can we find a list of the things that we need to remember?
from anywhere, like you can do just Google. If you do the Google, if you're asking the Google, they'll give you some seat. Okay, there may be
So
some.
like this can be taken as a standard form of this limit. I'm just asking.
Yeah, you can take it as a standard form.
Okay.
And how many of these exist, sir? Like in the lecture, there were, I think, 4 that was taught.
Yeah, 4 or 5, I think. Yeah, exactly.
Only 4 or 5. Okay, but that I guess won't be sufficient.
Like for tan
other
x by x is there, log
way,
1
Vishal,
plus
is
log
that
x.
we can make one file and upload as a
Okay,
part
that
of the
I can do it. Yeah, that I can do it.
or as a part of the supplements data. No, we can put it. Ideally, this should be integrated into that videos. Okay, or as a tutorial, whatever, so that it is a prerequisite which we understand. So sometimes what is happening is in the lectures we are going through the lectures, and when we come to the activities or the practical assignments, there are new forms of formulas that are used which are not done either until that video or in the previous courses.
Yeah,
And suddenly
correct.
new things are brought in, and we get stuck here. For example, I never knew that x by tan inverse of x equal to 1.
Okay, so I'll do it with the other method. Okay, because okay, I'll do it with the other method. So
that is okay. You can do it other method, but you also ask your instructor or somebody to upload all those formulas which are prerequisite.
yeah, see, if you can find this one for sure anywhere, like it's not been taught. Okay, I can know this limit, but this you can remember it. Okay, like there are some 20 to 30 things that limit that you have to remember just to solve the problem quickly. Nothing else. You can do it with the basic method also, but that will take your so much of time. This you can remember. Okay.
The opposite is also 1 equals to 1. Like x by tan inverse x is also equal to 1. Like just now you have told that.
For the sign also it's happened, right? For the sign also that happens. See, I'll tell you. See how will you get this. If you have, let's for example, x upon tan inverse of what, here it was 2x, right? So if you are putting limit x tends to 0 plus, so this is also 0, this is also 0. This becomes 0 upon 0 form. Correct? Now how will you do that? Can you do that? L Hospital, can you use that? This becomes 1 upon.
Yes, sir.
What is the formula? 1 upon 1 plus
So 1
2x
by
whole square.
1 plus 2x whole square. Yeah.
Correct? So now if you're writing it here, just in this form, this will go here, right? So 1 plus 4x square, correct, upon 2 or what? This is 2 or what will happen?
No, sir, it is 1 only. Yeah.
So how did you get tan like 1
Okay,
by 1
no.
2x square?
No, there should be 2, right?
Yes, multiplied by 2.
Multiplication of 2, because tan inverse x ka differentiation whenever you do,
that is 1 by 1 plus
you
x
get
square.
1 plus x square. So if you have 2x, so you have to differentiate this whole and then 2x. So then you will be getting 2x here. 2 here, basically.
2. Yeah.
Right? And if you are putting limit, okay. So let's, for example, you were taking x upon tan x only. tan inverse x. So this was also 0 upon 0 form. So if you are doing it, 1 upon this becomes 1 plus x whole square. So this becomes 1 plus x whole square. And then if you are putting 0, you'll be getting 1. Correct?
Yes, sir.
Here, how much we are getting? We are getting 1 upon 2. Is this clear to everyone, or I'm just speaking to only one guy?
Yes, I understood.
You understood, right? Everyone understood
Yeah,
this, right?
Derivative of tan inverse x is 1 by 1 plus x square, and then we like do what is necessary for tan inverse 2x, right? Like,
Correct. So this we are getting in the
yeah.
end. And then you can put it 0 here. So this will get cancelled. So you'll be left with 1 upon 2. Correct? So this is the first method that you can use, L'Hospital. The second thing is, I told you, you can use directly this one, tan inverse 2x. So what you can do is, 2 you can multiply it here and 1 upon 2 here. So 2 get cancelled. So you can do it, right? 2 multiplication in the numerator part, 2 in the denominator part. Now, you already know that you can think of this 2x as a y. So now you are left with what? If you have 2x 1 upon 2 by tan inverse 2x. So you can take 2x as y. So you're left with 1 upon 2 y tan inverse y. And as this was a limit, x tends to 0 plus. So if x tends to 0, y will also tends to 0. So this becomes another limit where y tends to 0 plus. So now this you are already knowing. 1. So again the right hand limit will become 1 upon 2. Is this clear to everyone or not? So the two method I told you, one you can use L'Hospital, or you can use directly this one. Is this clear, or should I explain?
Clear, sir. Clear.
Yes.
Okay. So now what was the LHL? The left hand limit. What was the left hand limit that we got?
X.
X we can't get.
The left hand limit we have got A.
Yeah, so left hand limit is A. So, and we already
Is
know
it
that.
A or X?
That is A, right? That is A.
Okay. Oh, A. What?
A. Okay. Now we already knew that for continuity, for any function to be continuous, what are the things that we know? LHL should be equals to RHL, should be equals to the function value at that particular point. Okay, now we know that RHL is 1 upon 2. What is LHL? A, right? And what is FA? What is the function value at A or at x equals to 0? What is the function value at x equals to 0? B, right? So you can put it here, B. B. So this is not A, this is 0. 0. So this is B. Correct? So now you can see that A equals to 1 upon 2 equals to B. This should be your answer. Is this clear to everyone, or should I explain it again? Or what do you want me to explain? Do you want me to explain it again, or is this clear? Can we move to the next part?
Got it, sir.
Okay. Let's move to 8.2, I guess. 8.1, anyone has any issue? Any of the question now?
Sir, you said x by tan inverse x and tan inverse by x or like returns the same one, right? Because
yeah,
we do it by just taking 1 by tan inverse x by x, like.
Okay, so if you're taking tan inverse x upon x also, limit x tends to 0. So this also becomes 0 upon 0. And if you are doing 1 upon 1 plus x square into 1 upon 1. So this also becomes 1, right? If you are putting x here,
Yes,
x equals to 0. So this becomes 0. Correct?
Okay.
Yeah. So one thing is,
so either we need to learn these limits, or we need to understand like derivatives of tan inverse x and all, right? Like what?
Yeah, some I guess 20 to 30 limits are there that you should be like you should be knowing.
So Vishal, these are
like
trigonometry formulas, is it?
What? Yeah. In the form of trigonometry Mostly it will be in the form of trigonometry only. But in the exam, I like whatever the paper I've seen, like not much trigonometry stuffs are there. Like it's there. I'm not denying it, but there are not much.
No,
Like
but Vishal, when I see not only the data from this course, if I see in many other areas, right, whenever the limits problems are there are much more problems with trigonometric functions. For example, limit of sine
yeah,
x of
that's why I'm telling you to. You can just remember, or like, you should be knowing how it comes, but at least in the end, the only thing is that will help you in the paper is like, or maybe to some like calculate it quickly will help you if you are aware of those facts, right? Some of the facts, at least 20-30 are there, and with the practice, you'll be able to remember all those things.
Sir, how weightage is divided in quiz 2?
Yeah,
Week
it's like from week 5 to 8. Yeah.
5 to 8, but weightage, sir, 5 week, 6, 7, 20, 20, 20.
It's almost same. Yeah, 25% from each week. Like you can have one question, like it's almost like same type of concept, right? Limit, continuity, differentiability. So you can't say in
Actually,
which week. Yeah.
in quiz 2, 1 to 8 is the syllabus, na, sir?
It's from 5 to 8.
5 to 8, okay.
Yeah, but if there is some concept that is used in 5th week from the 4th week, you can't say that's coming from 4th week. Are you able to get me? So there won't be as much as the paper have seen, like the most of the questions from 5 to 8, but if there is some concept that is using the concept from week 1 to 4, concept while solving the problem from week 5 to 8, you can't say that it's coming from week 4 and all. But the final quiz will be from whole, like from week 1 to 12.
Vishal, related to a similar problem, no, there was one problem which I was trying. Can I just write it down? I will try to explain.
Yeah.
So limit of tan inverse square bracket cos of x.
Okay.
It's a square brackets, means greatest integer.
Oh, okay. This is greatest integer, but I don't think so. They'll ask you this type of problem.
And x tends to pi by 2. Now, how do I find the limit exists here? How do I find the RHL, LHL?
This is a difficult problem. Why I'm telling you? Because first of all, this is what? This is a greatest integer, or what you told?
Greatest integer, yeah.
Huh. So this first of all the greatest integer, and then you should be knowing much. So this becomes so you should be also knowing about the cost function nicely.
The cost function means it's graph or graph. I know. What else I should know about cost function?
Yeah, graph itself I can, and this is pi by 2. It's just asking whether a limit exists or not.
Yes. Yes.
Okay.
The question is limit exists or not. So for that to limit to check whether the limit exists or not, I have to find LHL and RHL, right? If both are same, then the limit exists.
Yeah.
So now if I look at looking at the LHL part, so this is nothing but tan inverse of cos of pi by 2. Should I go that way?
Okay, so
Sir, it has to be a value that is lesser than like pi by 2, right? Like left when we consider equating it directly.
no, so it should be lesser than pi by 2. But this problem you can.
We have to consider in two ways, right? A value lesser than pi by 2, that is pi by 2 minus what we call.
Yeah, basically
and pi by 2 plus
pi
we have
by
to
2
consider.
minus, and this should be equal to limit. See, first you should be knowing the tan inverse ka plot also you should be knowing, because the thing is, because the value will, whatever the value if you are putting here, See, let's for example, at cos pi by 2, what is the value? If you're taking cos pi by 2 minus, what is the value you'll be getting?
Cos pi by 2 minus.
Huh.
Is it 0?
No, cos pi by 2
Value
minus.
greater than 0.
This is pi by 2. Correct?
Pi by
And if you're
2
taking, yeah,
minus.
so first you are coming from left side and then you have to come from right side. So if you're coming from left side first,
Right side, correct.
and if you're coming from left side, so this becomes tan inverse of this is the greatest integer. That means like you just have to take the minimum value, right? If it is what? If it is somewhere, let's for example, if
No,
this is
Vishal, if
cos,
we tie pi by 2 minus is some value which we don't know, but we are interested only in the greatest integer, correct?
no, you have to first take the cos of pi by 2 minus, and then you have to make that greatest integer. Are you able to get my point?
No, cos of pi by 2 minus, which is a little bit less than pi by 2, cos of pi by 2.
It will be a
so
value
that-
greater
Okay.
than 0,
So
right?
that
sir?
value we don't know, but it will be some value,
Yeah.
right, on the graph.
Correct. So it will be some value that will be greater than 0. Let's for example, this is the
It
value.
will be greater than 0, but we will take
Okay,
only the integer part of it.
Let's for example, this is pi by 2 minus. There will
Yeah.
be some greater than 0, correct?
Yes.
So what value
And-
will be taking? Tan
and-
inverse of what value will be taking?
0, na, sir?
So any value will be taking 0 only, correct?
Hmm.
So
Any value?
Any value means from 0 to 1.
Okay, sir. Okay.
Okay, if this is like from 0 to 1, it will be taking 0 only. So tan inverse
Yes,
0 is what?
0.
0. So your limit LHL is this one. Now come to the RHL. If you are coming from pi by 2 plus, pi by 2 plus is what? Some negative value. If you are taking some negative value, then this function will become what? Tan inverse of cos of pi by 2 plus. So this is a negative value, some negative value, correct? Correct or not? This is some negative value.
Sorry,
And if you are taking,
cos of pi by 2 is 1 or 0?
No. So I am coming from right hand side, right? So to calculate the limit, I have to come from the left hand side and right hand side, right? And both the values should be equals to some particular value, some random, whatever the value you are getting. So here I am getting from LHL, I am getting 0, correct?
Yes.
So from right hand side, if I am going from right hand side, this is some pi by 2 plus h. H is some small value.
Yes.
So this, let's for example, this. So at that point, cos value is what? Some negative value, correct? This is that
-1,
value. Not -1. No, cos pi by 2
We're
is what?
taking
0,
greatest
right?
integer, na, sir?
Correct.
Then greatest integer will become -1.
Since we take greatest integer, it will be -1.
So tan inverse -1 is not 0. So that's why the limit doesn't exist for this case.
Okay.
Got it, right?
Understood.
Tan inverse -1. What is tan inverse -1, sir?
I guess it's like 45 or not 45, -45.
-45
minus
or
will be-
135 degrees.
Sir,
So we need to
Yeah.
know these values, like tan inverse 0, tan inverse 1.
Yeah, see, if you have to solve this, first of all, I don't think so they'll ask you, because many of you are not aware of tan inverse function and all. See, and one more thing, if you will get some difficult problem, no? Because I can remember that one question was there that was very difficult, that was related to trigonometry, but in the end we removed that question because we thought the differentiation of this thing people doesn't know. That's why we have excluded those problems. Okay, so that's why I'm telling you, but it's better you should be knowing. But in the exam and all, there won't be any problem that is not been taught, any of the function that is not been taught in your lecture.
So we will learn all this at a later date, is it, Vishal?
With the see maths too, I'm not sure whether you'll be.
I'm pretty surprised because in the course we are using a lot of like this, okay? Because when I see, as I said, so many questions on limits are with respect to the trigonometry. And if we are learning trigonometry at a later date,
No,
this means that
trigonometry, I don't think so it will be taught, trigonometry particularly, because this is the maths that most of the people should be knowing from class 10th, class 10th or 9th. But yeah, inverse and all that you have to, I guess, learn it from your side itself, because I don't think so inverse anybody will be teaching you from in any of the courses, I guess. But I'm not sure if maths 2 includes that or not. I need to check that whether the inverse function are there or not. But in the JE and all, whenever we used to study there, in I guess 11th or 12th, the inverse function was there. But most of the people doesn't do that. Like if somebody is not from that maths background, so then should not have studied. But yeah, so some function you can learn it from your side. This is what I hope you have to do. Some function, not all, but most of the things will be taught here. Like, okay.
what about others? Are you all quite comfortable with this?
I'm not. I'm like learning like new.
With time it will be fine. Like it's like only 1-2 week you have studied limit. How can you be pro in that? Like with the just practice and all will be fine
No,
after
no. What
some time.
happened? I'll tell you the problem, Vishal. When we are not able to solve some problems, no, there will be a little bit of anxiety because we have spent so much time in looking into the videos.
Correct. I can
Right?
understand that. Understand. Yeah.
5 to 10 hours we have spent on it, and if you have to take the notes again, double that hours. 15-20 hours we spend. We take all the notes, and when we come to the problem and we are not able to solve, the anxiety will get. Either we feel that
Correct.
we don't have any
Yeah,
prerequisite
these are
knowledge
the
that is
weeks
required.
that it needs serious like more attention. Some weeks like limit, continuity, and differentiability, like because much of the chunk has been taught earlier. It was in the maths like second part of the math, but now it has been included in the first part.
Yes, sir. Same
So it
problem
will be
I
very.
experienced.
Okay.
It will be very useful
So
if we
see,
can like upload like a PDF of these limits and the differentiation
it's already
formulas
there,
we need
right?
to
There is a
know.
one book that has been uploaded. All the stuffs are there.
Actually,
One.
yesterday I watched the 8.3 lecture and I दिन भर में बैठा रहा, मेरे को सॉल्व ही नहीं हो रहे थे कुछ क्वेश्चंस.
Okay.
पूरा वो बुक भी छान निकाला, मतलब क्वाइट हार्ड है.
Okay, so you can take help from the, like you can just ask me whenever you have a doubt. You can just mail me your doubt, whatever you have. That much I can help. I can have more some extra session, non-official session type of things on the Gmeet and all.
Yes,
But
yes.
yeah, that
So
that
can you
much I
make
can
a
help you.
group, little group of little group with students for
In Google
unofficial?
Space.
First go through that. You have a doubt, you can just mail me. I gave you your mail ID, right? Vishal at the red
I don't
study.
have your mail
Okay.
ID.
No, it's there in the chat.
So you can just mail me whenever you have a doubt. So yeah, so this is what, and then we have now before quiz we have time, so we can discuss some more. We'll be having some more sessions. They will be discussing. Okay, now can we discuss the doubts that you have, and then after 10:30 we can discuss this. Okay.
Okay.
Yeah.
Yes sir, go with 8.2 with proper, मतलब सब concept ही बता दीजिए.
8.2, what is there? Okay, let me check it. 8.2. Yeah, tell me the question number that you have a doubt, or should I go like all the
Sir.
questions?
Sir, question number 3, 8.2.
Question number 3. Anything else?
No, sir.
So the mail ID is not available in the like seen in the chat. Can you like scroll up? Okay, sir. Thank you.
See here. So I told you. So some basic concept. So differentiability is there. Right? Tell me when when is the function you can call that is a differentiable and or it's not a differentiable function? How do you check that?
If it is continuous, then it will differentiable.
No, this is the
Like
wrong assumption that you are making.
limit
First,
LHL equal to RHL equal to f of that x. What
uh,
at
Sir,
that point?
when
limit h
right hand
tending to 0 f of a plus h minus f of h by h if it exists, then we say
correct,
it's
correct. So to check the function, whether the function is differentiable at some particular time, like at some particular point or not, you have to check one thing, right? Can you tell me again? I'll just write it.
limit h tending to 0.
Correct. So limit h tends to 0, function of a plus h minus function
F of
of
a
A.
by
a.
h.
Yeah. So if this exists, then what can you say?
The
Then this
function is
function is
differentiable.
differentiable at what point?
At
point
a.
At A. At A. Yes.
Differentiable at a. Correct. And one
Yes, sir.
biggest misconception is the first point is that you should be noting if f is a function that is continuous at a, that means it is differentiable at a. Is this a correct statement or false statement?
So false statement.
This is false. This will not hold always. Okay. If you are saying that a function is continuous at a and that means it is differentiable also at a, it's not a correct statement to make it always. Let's, for example, I'm just giving you one thing. This is a function. This is equals to mod x. Can you tell me whether this function is continuous at 0 or not?
It's
Yes,
continuous.
sir, continuous.
Is it differentiable at 0?
No, sir.
No, sir.
It's not differentiable at 0. Okay. Can somebody
Yes.
calculate the thing that I told you to calculate this? Can you check with this method for this function? For mod function, can you check it?
Yes, sir. It will be minus plus 1 or minus 1.
Yeah. No, first everyone, I'm just asking everyone to solve this one. Can you solve this or should I try? Okay, let's, for example, fx equals to mod x. This is the function. Now I told you you have to check whether the limit exists at x equals to, because you have to check at x equals to 0. Okay, now check it. You have to check it limit h tends to 0 f of a plus h minus f of a upon h should exist. It should exist. Okay, now for this function, what is the value of f of, so we have to check at x equals to 0, right?
Yes, sir.
Not x, it's like a is equal to 0. Correct?
Yes,
Yes,
sir.
sir.
Now put the value. If you are putting the value of x here, the function value at a plus h is what? Mod of
H.
a plus h minus
Mod of A.
Mod.
upon h. H tends to 0. A you already know, a is 0. So this is left with what? Mod of h upon h. Now one thing I told you, if you have to calculate, first you have to check whether the limit exists or not, or at x at 0. Okay, for this, what will you do now to check whether the limit exists or not? How do you check that? Can somebody tell me how do you check whether the limit exists at that particular point or not? How do you check that? LHL?
Left limit, right limit.
Left hand derivative is equal.
Left limit and right limit should be same.
Yes.
Okay, so for to calculate the left limit, I should be coming from left side. Left side is 0 minus, right? So limit
Yes, sir.
h tends to 0 minus. What is the value? What is the value? It
Minus
should
h.
be what? This is minus h upon h. This is minus 1. Now I am coming from right side now. H tends to 0 plus. Now this will be positive h upon h. This is 1. So is the LHL equals to RHL?
No, sir.
No, right? So that means LHL is not equal to RHL. So what can you say that limit does not exist? Limit doesn't exist for this case. That means this function is
Not
not
differentiable.
differentiable.
Sir, in bracket h will give us absolute value, na sir?
X equals to
Sir,
what absolute value? What?
limit h
No, see.
tends to 0 negative.
Okay. 0 negative, you can think of, let's for example, you are thinking 0 minus 0.5, 0.5 minus of this value. Okay. So if you are putting this value here, what is the value you will be getting? This is h, your h.
Yes.
If you are putting this minus of minus what? Positive, right?
Positive, yes.
So that means this is minus h you are getting.
Okay.
Right?
Okay.
Sir, in the third last step,
Okay. This one?
or the third last step, sir, like mod x plus h before that.
Okay.
Sir, here in this step, sir, how did we directly cancel mod x plus h minus mod x? We cancelled mod
A
x.
is tending to
Is it
0, right?
possible?
A is 0 because we are checking at A is equal to 0, right? We are checking the differentiability at 0. So that's why this becomes 0, this becomes 0.
Okay, yes, sir.
Yeah. Anyone has any issue in this limit, this differentiability? So that's why this should be there in your mind. Yeah. But the second thing is, whenever this is differentiable, then you can say that this is continuous at that particular point. Okay. This is clear? If at any particular point, if the function is differentiable, that means it is continuous also. That is correct.
Sir,
Is it clear to everyone?
Sir, in the lecture 8.2, there is a proof to show this. So in there, one of the last steps is limit h tends to 0, f of a plus h equals f of a.
Okay, I need to check that. What is that? But okay.
So they did this limit h tends to 0, f of a plus h minus f of a by h. And
Okay.
they took another limit h tending to 0 of h. So that will be 0. And we are saying that the function is differentiable. So limit h tends to 0 f of a plus h, it exists, right? So we put it to be equal to L. And limit h tending to 0 of h equals 0, because limit h tending to 0 of h is 0, right?
Vishal,
Yeah, you can do it like this. Yeah.
Hari, whether you want to share it, because we are not able to understand.
This is in the lecture 7.2. Like the teacher proves it. Like he proves the fact that if a function is differentiable, it is continuous. So
Okay, you can think in that way. Yeah. Whatever you have said is totally correct. So whatever he said, see, I told you two statements. The first statement is if a function is continuous, that doesn't mean it is differentiable also. But the second statement is if a function is differentiable, that means it is continuous. Okay, the second statement is totally correct. Now the thing is, the second thing is we have to prove that. Okay, there's no need for that. Okay, if you're asking, we can do it. Like whatever he told, it's like absolutely correct. Because you have to
So
check
here-
that limit h
Limit.
tends to 0, it should exist. Right?
Yes, so A equals to L. So he
If
just
this
took
is
a
exist,
random.
then you can take. Yeah. So you would have taken
Uh,
something like that, right? Limit he would
Yeah,
have
he
taken.
took a random value, like it is equals some value L.
Yeah, we can take
Because
it this thing. Okay, we can take this as a limit, this as a function. Okay, and can you multiply h upper side and lower side also h? Can you do it?
yes,
Okay, and what is the information
and
given is it is differentiable, right? If it is differentiable, that means it exists, right? This function exists.
yes, sir.
Correct?
And
Now, if this is exist, that means this function will become how much? This is how much?
0. It will go to
0,
0.
right? This is 0. So this is like 0 multiplication of limit h tends to 0 h. Or let's, for example, this is not 0. You can take some random value also, L. So whatever you have told, L we can take it. Or any
Yeah.
fact you can take, right? It's like not always 0. There can be some exact value, right?
Yes, sir.
Correct?
Yes, sir.
So this is basically the differentiation, like differentiation for that particular function at that A. So this can be L, right? But this will be 0, right?
Yeah, yes, sir.
Okay. So this will become 0. So this means you are calculating limit h tends to 0 if A plus h minus if A of how much? H,
F
sorry,
of
A
F
is equals
of
to
A.
0. That means
Yes, sir.
f of A plus h is equals to f of A.
Sir, here limit h tends to 0, f of A plus h equals A. Now we can, as h tends to 0, I imagined it as like the x-axis. We took this value A, right? So
Yeah.
as h tends to 0, this x value tends to A. So it can be rewritten as limit x tends to A of f of x. Is my understanding correct?
Can you repeat it?
In the next step, sir writes limit x tends to A, f of x equals f of A.
That is correct.
My question is, that is happening because as h tends to 0, in the x-axis, our x value is tending towards A. Is that correct?
Correct. Yeah.
Oh, okay. So we did transformation, right? H tends to 0, x tends to A is like a transformation.
Correct.
We are checking
So
as
that
h tends to 0, where does x tend to?
Or
Oh,
you can
okay.
think in that way also, because see, this is basically equals, right? So now you can think of this way as this limit is equals to fa, and this holds when we have a continuous, right, function. That means limit of 0, that means we can write it like this also, 0 plus equals to limit of 0 minus equals to f of A. This
Yes,
is for the continuous function, right?
yes, sir.
Correct. So we have started from the differentiability, we reached to the continuity. It's not important the proof. The one statement is important. Like if
Sir,
a function
no,
is
it's also
differentiable at a
important
particular
to-
point, then it is continuous for sure.
Sir, it's important to state that limit x tends to A of f of x equals f of A, right? That is when the proof is complete. Like,
You see here, if you're writing h tends to 0 or not, that doesn't mean like not making any sense, because there is no h, right? This is the particular function value at particular, like fa is like the function value at A. There is no h. It doesn't contain any h or any variable, right, that you have to put. So you can directly write it like that. So it's like basically simply like limit x tends to h, and this is a constant function k. It's not making any sense, right?
No, sir, my point was, like we say that the function is continuous when it is given as limit x tends to like some h x tends to a, f of x equals f of a. Like
Huh.
that is how we say it, right? Like
Yeah, we say it like that, Bhuvan.
so from this we need to go to that, right? So that is where I asked, like the same limit h tending to 0 is the same as saying limit x tending to a, because as h tends to 0, x tends to a, and the function value also like is f of x. So from this step I can write the next step as limit x tends to a f of x. Is my
Correct. Yeah, correct.
okay, sir, thank you.
Yeah. So this is done differentiability. I guess you'll be able to now. So whenever you have been asked to calculate the differentiability or maybe the differentiation, see, all the differentiation basically comes like this way only. You generally calculate this thing only. This is the thing that you calculate to calculate the differentiation at any particular point. Okay. Whatever you're doing, differentiation of x or anything you are doing. Okay. Let's for example, your function fx equals to x. You have to calculate the differentiation. You can do it with this method also, right? This is what? How will you calculate this? X plus h minus
X by h.
X plus minus x by h, right? This is limit h tends to 0. So this x got cancelled, so you have h upon h. So you're left with 1. So this is the differentiation. The differentiation of x is 1. So this is what you calculate, right?
Yes, sir.
And you have to check for the differentiability. You just have to calculate the limit for this fx plus h minus f of x upon h. This is what you do every time.
Yes.
Okay, is this making any sense to everyone?
Yes, sir.
Yes, sir.
Correct. Okay, can we do it for the sin x? Can you do it for the sin x? What generally we have to calculate, if you have to differentiate this, we have to calculate d of fx upon dx. This you already know that this is cos x. Correct? How will you do this? Sin x you have, so basically write it limit of h tends to 0 f of x plus h minus f of x upon h sin of x plus h minus sin of x upon h. Can you expand this? This has been taught, right? So this you should be knowing. Sin x plus h.
Yes.
What is the value of sin x plus h?
Sin
Plus
x,
cos
sin
x,
x,
sin x into cos h plus cos x into sin h.
Yeah, first take sin x, then the remaining part is h. So take with cos, and again take x with cos now, and then sin. Now this is minus of sin x upon h. Limit of h tends to 0. What will you do now?
Cos,
What is the next step we should be doing?
sir, we can take sin x
Sin x
combined.
common. Not common.
Sin x common, okay.
No,
What
sir.
can you do now?
So how we can take this?
Okay.
Cos h minus 1 whole divided by
Plus.
h
Plus cos x into
cos x sin h.
Sin h is there.
This is h and this is h. So you can use limit here also. So what is the value of this? This one limit. You already know that limit of h tends to fx plus gx is there. You can use it separately also. Now tell me the value of this.
This is 0.
If you are putting h or 0, what is the value you'll be getting?
But sir, it will be like below it is h, so it will be like,
yeah, it will become sin
so you
x
cannot
into
directly put.
yeah, we cannot. No.
cos h minus
we
Can
multiply
you
h.
use? You can't use it, right?
Yes,
Sir, we
sir.
L
multiply h.
hospital.
The L'Hopital's rule we can use.
Sir, we
Yeah.
can
Now this.
multiply h.
We get minus sin h by 1, which will be 0. First term will be 0 and second term will become 1. Cos x.
But we
Okay.
have sin x and h, na, like, so two, like, what
Sin s is
derivation?
some constant value. This is some constant.
Yes,
So
sir.
we can multiply h both sides, numerator and denominator. H times cos of h minus 1 h square. We can get
What can you do?
1.
Can you tell me?
So we can multiply h numerator and denominator both sides.
Okay. Again.
So,
Okay.
sir,
How is it
h
helping us?
no sir. सर बाहर इस कोस का बाहर ब्रैकेट का बाहर.
Okay, bracket के बाहर. Okay.
No sir, no.
So this is some constant you have to put. Okay, now come to this. So if you are putting h here 0, this will become what? So this you already know, like limit of
1 minus cos h has an expansion, right? 1 minus
no
cos
okay.
h.
So do not go to the expansion. First come to here, like this one. So you have now here you can put it, right? Sin h upon h will become 1, right?
1, yes, sir.
With cos x, correct?
Yes, sir.
H tends to 0. So this becomes a constant. So from here you are getting cos x. From here, what are the things you are getting? Sin x multiplication of. Can you do the L'Hospital here? 0.0. So left with what? Sin of h upon 1. Limit of h tends to 0. Can you put it here h equals to 0? This is basically minus of. If you are putting it here 0, you're left with 0 multiplication of some constant. So this is becomes 0. So you're left with cos x. So the differentiation is what? Equals to cos x. Is this clear to everyone? Is this clear to everyone?
Yes, sir.
Yes.
Sir, we do this L'Hospital rule when it is 0 by 0, and we do it as till we can remove it. Like as soon as we remove it from that form, we stop.
Yeah. You can, till the time you are getting 0.0, that interdeterminant form, you can use it. Okay. So any issue in the differentiability? Everything is clear, right? Is this clear, everyone?
Yes, sir.
Yes, sir.
Yeah. So I hope okay. So we'll just discuss some problem, and then we'll end this. Maybe you can ask your doubt anywhere, at least on the mail. You can ask me your doubt. Maybe if you have any particular session, like any group and all, if you want me, I can join it. We can have some more discussion there. But I'll just discuss some problem here.
So I have a doubt in activity 8.3.
8.3, 8.2 we are discussing, right?
Okay.
Sir, this group, like, is it like Google Space? Because
You can make it whatever you want to. Yeah. So I'm absolutely fine with anything.
Like WhatsApp group also is like fine. Like,
yeah, it's fine for me. Yeah.
So
but for
sir,
that you
like
have to mail me first. Then I can give you the WhatsApp number. I can't give it.
Okay, sir.
Yeah. So okay. So what was the problem that you were facing? The problem you were facing in 8.2. Which question? So just discuss some 1-2 problem and then we'll wrap up. 8.2. Any which question you have a doubt?
Sir, I have a doubt in third question.
Okay, so the third problem is what? What was the third? So fx. This is what? This is greatest integer function, right?
Yes, sir.
Okay. This is greatest integer function. So for x greater than equals to 0, and the below one is the
Scaling function.
okay. So this is the this is sailing, right? Or the
Yes, sir.
the upper one is the floor one. Okay. Okay, I can't see it correctly, but I guess this the screen that I can see is the top, the floor one, and this is the ceiling. Okay, let's come here. Okay, is this function differentiable? The first option is the function is differentiable at 0 or not. So yeah, so whatever I told you, now you just check it this one. Okay, you just check it with this. I guess you'll be able to calculate it. Okay, you can just I'll just do it for 1 point. Let's for example at x equals to 0. If you have to calculate it for this, so you have to check for both the cases. First put h tends to 0 plus, and then put h tends to 0 minus. Okay, and then check that whether the limit that you are getting is both are same or not. And if this is same, it's like differentiable. If it's not same, then you can directly say it's not differentiable. Okay.
Okay, sir.
Yeah. So did you try this problem?
Yes, sir. Actually, I have a doubt in a sign. What is
Sine? There is no sine function, right? Sine means okay. Sine. Okay.
No, sir. Scaling function.
Okay, tell me if you are taking a 0 plus, what should be the value of this function? If you are taking 0 plus, which one you should be taking?
Floor.
Yeah, floor. So for 0 plus, tell me the value that you will be getting. If you are taking 0 plus h.
Yeah.
Or some 0 plus is small, if you are just increasing
Zero.
some value. What is the value you will be getting?
0, right?
0. Okay. So this will become what? Fx plus h.
So x will be the 0 and h will be the 0 nearest to the 0, na sir?
No. See, h is 0 plus, right? 0 plus.
Yes.
Let's for example 0 plus some value p. P is some constant.
Yes.
It's very small. Okay. And 0 minus
Yes.
p is very small. So this is less than 0. This is basically less than 0. This is more than 0. Okay.
Yes.
If you have
Yes,
a
sir.
0 more than 0, that means you will be using this function.
Yes, sir.
Correct. And if you are using this function, what is the value of this function? If you are using a slightly greater than 0 value,
Yes. Yes.
what should the value?
0.
0, sir.
This will be what? This will be some x plus h minus x upon h.
X. Yes.
Correct?
Yes.
This value, what did you say? What is the value you'll be getting? X plus h?
0.
0. Sir, x tends to 0, na?
From the positive side. Yes.
Yes. Positive side. Yes.
See, we are checking the differentiability at x equals to 0. Okay, so the first of all, there should be very clear that here x is equals to 0. So this value can be any value. I can check for x equals to 10 also,
Yes.
right? So here x is equals to 0. So for the
Yes.
function, for this function at least, for this function where x is directly equals to 0, there's no tending toward anything. So this
Directly, yes.
x is equals to 0. We are checking for the x equals to 0. So this is 0. H is very small value. When h is very
Yes.
small, that is higher than 0. Okay, that means this function will become 0, correct?
Yes.
Yes, sir.
And this is how much?
0.
0.
Correct. So the value will be
0.
Yeah.
You'll be getting 0, right?
Yes.
Yes, sir.
Okay, because here you can't get confused with this h. This is tending, this will become a very small value. That is some p, right? I told you, right? H is what? H is 0 plus some p. P is some constant and that is very small. Okay, so you can't get confused with 0 upon 0. This is like very small value. So this is 0,
Yes.
right?
Yes.
Correct?
Yes.
Now take it from left hand side, 0 minus. If you are putting 0 minus, what should be the value of this function?
0.
So this was greatest integer function. It's a lowest integer function, right? This is a
Yes.
ceiling, basically, we call it. If you have less than 0, so it will be go upward, right? So this will be what? 0.
0.
Yes.
Minus 0 upon some p, right? So this will be all. So this is 0. That means at x equals to 0, this function is differentiable.
Yes.
Correct?
Yes, sir.
Yes, sir.
Yeah. I hope this is clear. Yeah.
Yes, sir.
So I hope so one I can just see, I'll tell you 3-4 things are there. You should be knowing the limit where it exists. Okay, and how do you check that? Limit of h plus should be equals to limit of h minus. The second part you should be knowing is the continuity at any particular point, at any point. And how do you check that? You basically do ls, same thing you have to do, just do one extra thing. Should be equals to wherever you are checking at fa, if you are checking, this should be equals to fa. The third thing is the differentiability. Okay, for the differentiability, I told you, you have to calculate the limit exists or not at that h equals to tends to 0, 0. Okay, and here it is f x plus h minus f of x plus. So this you have to check. The limit exists or not. If limit exists, this will be the value of dy upon dx. Correct? And we have done for x and sin x also. And the fourth thing is, what is the fourth thing you have read here this week? The linear approximation. Okay, this is the fourth thing we have discussed 3. Because this practice, so and one of the most important
Excuse me,
things
sir.
doing. So whatever 20-30 limit is there,
Yeah.
memorize that.
Excuse me, sir. So for the
While memorizing, should be knowing
differentiability.
how it is coming. Okay. Yeah.
So for the differentiability, sir, just now we have discussed. Because we have just now we have discussed the sin x. For the sin x, we are finding the difference if it is differentiable or not. But like sin x is differentiable at almost everywhere. Sir. Like at every point, sin x is differentiable.
That's why the differentiation came as cos x, right? If you are calculating at some particular
that
point,
is
the
fine.
differentiation. Yeah. Okay,
sir. So that is fine. Like, sir, if we want to like check for the differentiability for sin x, if you're doing it, so can you please move up above for that particular
Yeah.
So like first fx is equal to sin x. So if I want to find the LHD, left hand derivative. So for left hand derivative, limit of h tends to 0, f of x minus h minus f of x divided by in the denominator it is minus h. Okay, for LHD, I'm telling. So after like doing some calculations, I'm getting limit of h tends to 0, then sine of 1 minus h divided by minus h. So after that, sir, how you can go ahead? Just ask. Like
Sine of?
I'm getting, sir, limit of sine of 1 minus h in the bracket. Limit h tends to 0. H tends to 0. 1 minus h and divided by minus h. 0 minus.
What? 0 plus 0 minus.
The 0 minus. Not 0 minus, sir. It is x equal to 0 only. Excuse me, sir. So not minus. Yeah, h equal to 0, I'm telling. Limit h tends to 0. Exactly 0.
How do you get this minus h then?
So how I
How
got
do you get
this?
this minus
Like
h?
minus h is like, sir, for the left hand derivative. The formula is only limit of h tends to 0. Then f of x minus h minus f of x divided by minus h. No, sir, that is not minus. That is we are not doing that minus there.
Okay, start with the like.
So like, can we find after this?
No. Okay, let's start now. First, I should be knowing how do you get this.
So like, first you write this the derivative sign there. F what?
No. I'm asking how do you get this one also?
F dash.
F dash. I'm telling
you. So we'll write f dash of x minus f dash of x minus.
Wait. I'll start from the beginning. Okay, sin x was there. Okay, you have to calculate what?
Yes,
limit of h tends to 0. Sine of x plus h minus sine of x upon h. This you have to calculate. Now the next step. Tell me the next step. What did you do the next step?
So like we have given the function only that fx is equal to sin x, and we have to find the we have to check for the differentiability. That is the point.
I started with this one. Okay. Now tell me the next step.
So like I'm telling why this step, sir. Like we have started. We have the question for why is fx is equal to sin x only, no?
Sir, I think he's saying he's looking for the left hand limit. So
yeah, exactly.
Left hand derivative, sir.
Left hand derivative.
Okay.
For left hand derivative, f dash of x minus is equals to f dash of x minus.
Okay, let's start for the 0 minus. You say 0 minus, correct? Left hand.
Yeah, 0 minus. For 0 minus, yeah.
Only
for 0 minus.
LHD, correct?
LHD, yeah.
No, sir, he's saying a left hand derivative.
Okay, left hand derivative. Okay, fine. Basically, that is also a limit. Okay, let's, for example, this is LHD one. Fine.
So, yeah, for that particular LHD, we have f dash in the bracket x minus equals to. So, can you please write it? Then it will be clear.
Okay, tell me.
So, f dash.
Okay, f dash is fine. Okay, this is like left hand side, right hand side.
Yeah, and x minus in the bracket x minus f dash after f dash x minus. That is equals to limit h tends to 0.
Okay, sine of what?
They're not
X
signs, sir.
minus H.
Like
I think he's
not
telling
getting
the
the point. First
formula
of all,
for left-hand derivative.
The formula
sir, I
of
am telling the
X minus
formula first. Then only you will understand that how I get the sign 1 minus H by minus H. Then I
okay,
think
you're saying the formula.
my question, yeah.
What is the formula?
Sir, like f dash x
And
minus.
is this taught in the lectures?
Sir, I'm
Not
just
all.
asking because, sir, like it is not
Okay,
taught in the lectures.
okay.
But
got it.
but like I have studied in my like previous
F
classes
dash
11,
x
12.
equals to
F
okay,
dash
F dash
x
x equals
minus
to
x minus put in the bracket x
x
minus
minus.
equals to limit of h tends to 0, h tends to 0,
H tends to 0.
then f of in the numerator f of x minus h in the bracket x minus h minus of fx, and in the denominator it is minus h.
Okay, minus h. Okay.
Yeah. So sir, at x at x equals to
do it for this. Sine of
0
x minus h minus of sinus x upon minus h. Now solve it this one. Sin x cos h minus cos x sin h minus sin x upon minus h.
But I have not solved it like this, sir.
Correct.
So like we can directly see
How
that
did you
f.
solve this?
Sir, can you please erase the
Tell me how did you solve?
second and third? The second also.
Okay.
So like f dash of x minus is like we have 0 minus. Okay. So f dash of 0 minus is
dash of 0 minus. Okay.
Equals to limit of h tends to 0.
Limit h tends to 0.
Then f of 1 minus h. I put there 1 minus. Sorry, 0 minus h. Sorry.
Why
not
did
1.
you
0. So not 0. Not 1. It is 0 minus h.
Sine of 0
Not
minus
sine
h.
of, sir. Not sine of, sir.
No, but the function is sine, sir. So you can, I think, bro, the sign, the function is sine, so I think sir can directly put instead of writing the formula.
Okay. Yeah, sorry. Yeah, exactly.
Yeah.
Okay. And then, sir, f of 0 is nothing but 0 because sine 0 is 0.
Correct. Minus of h. Okay.
Yeah.
Now you're left with what? H tends to 0. Sine of minus h upon minus h. What is sine of minus h?
Minus of sine of h.
Minus of, oh, sorry, sir, not 1 minus h. I am getting. Okay. Okay, fine, sir. Yeah, correct. Minus sine of h, then minus will cancel sine h by h.
We are getting 1. Correct, right? What is the differentiation of sine x? Cos x. At x equals to 0, what will you get? 1. Correct, right?
Okay. Yeah, okay, sir. Fine, sir. So I got somewhere it is wrong. Sorry, sir.
Okay.
But fine, I have understood this.
Okay, no
sir, if minus sine h, h will be 0, then sine 0 will be 0, na, sir?
What? Sine 0 will be 0 for what?
The value of sine 0 is 0, na, sir?
Sine 0 is 0, correct. But
yes.
This is some value, right? Some value closer to 0.
Okay.
So that's why we are using 0 upon 0. You can use it in hospital directly.
Can you explain last step?
Last step is, see, you have something, right? Sine of minus h upon minus of h. Correct?
Yes, sir.
We have to write it like this, right? Minus of h minus h is got cancelled.
Yes.
Now you can write it. This is 1, correct? Because you read for this. You read it for this, right? Sin x upon x. You didn't read for this one, right? Did you read for this one? You didn't. You read for this one, right? You read for limit x things to 0. This is 1. So that's why this
Yes.
becomes 1.
Okay.
I guess this is clear to everyone?
Okay.
Okay. So I hope this is clear. So again, we'll meet in the next session. When is that? I don't know, but
Sir,
we'll meet. So you can just mail
Thank
me
you, sir.
wherever you are finding it difficulty. Yeah, thanks everyone. Yeah. Whoever has any doubt, you can just mail me or Gchat, anything, whatever you want to call, like do it, you can do it. Okay, I'll help you.
Yeah, hi guys.
This weeks and all
For
is
those who are interested, you can type in your email IDs. We can do a group as a part of the mail, include Vishal also. So, and if you have any doubts, we'll start interacting through mail ID. WhatsApp, I would not prefer because in WhatsApp, again, the messages and all will get deleted after some time.
so okay. Gchat, I guess it'll be fine. I guess. Okay, so yeah, anything you want to do, you can do it, right? Anything will be fine for me.
Sir, I have a doubt in 8.3.
No, like we're done with today. It's already
Huh?
late. We have a dinner also. We didn't have-
Sir, can you take that doubt, please?
Okay, which one? Tell me quickly.
Wait, I am just opening my checking. Wait, sir.
You can send me that. Just send me the screenshot. I'll send
Or,
you.
or sir.
I'll send you the solution. Please send me there. Okay. Mail me or Gchat also. You can find me. Just send me the
Okay.
screenshot. I'll share you the solution. Okay.
Okay.
Yeah. And if you're finding it difficulty there also, you can. I can contact you by call or whatever you want to. Okay. Okay. Yeah, thanks everyone for joining the session. And then I'll ask them to close.
Hello, Shiva, are you there?
Yes.
So, are you making what that गूगल न्यू गूगल वो अभी लॉन्च हुआ है उसको क्या बोलते हैं गूगल स्पेस ग्रुप
मुझे पता नहीं है कैसे करना है
ओके मैं बना लूंगा मेरे को मेल पे हाई कर दो
चैट पे
हाँ
हाँ
मेल मैंने तुमको मेल ईमेल आईडी भेजा है मेरा
योर नेम इज अथर्व इज इट
यस मैंने स्टूडेंट ईमेल आईडी से भेजा है क्योंकि पर्सनल ईमेल से मतलब बहुत मेल आते हैं तो स्टूडेंट ईमेल आईडी ही बेस्ट है
गूगल चैट में बोल दो कौन सा है आपका आईडी चैट में डाल दो
डाल दिया मैंने चैट में डाल दिया है
यस
मेरा स्टूडेंट आईडी नहीं है
you
मेरा स्टूडेंट आईडी नहीं है
क्विज वन में तुम क्वालिफायर हो ना
यस यस
ओके 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 नो प्रॉब्लम एक्चुअली ये मेरा सेकंड टर्म है मैंने लास्ट टर्म में स्टैट्स और इंग्लिश लिया था वो तो मेरा अभी क्लियर हो चुका है इस टर्म में मैंने इंग्लिश और सीटी लिया है और इंग्लिश 2